and so far so good. And the title for my presentation today is on teaching and learning cybersecurity courses with virtualization technology. So in this presentation, what I'm trying to do is to sort of share with you and with colleagues sort of a reflection of what I've been doing in my classes. Because throughout my academic career, I've been a lecturer with different institutions teaching cybersecurity courses, networking, advanced networking, and the Internet of Things. So my presentation today is very much around what I'm doing in my classes. Okay. These are the outline of the presentation. We're going to look at some of the issues on how we can enable our students beyond the classroom, but more specific to teaching courses related to cybersecurity. We're going to look at what is a virtualization technology and how we can use this virtualization technology, or how I use it in my classes to teach cybersecurity courses. I'll also share with you some example of environment set up for experiment, and some sample of experiment that we can see how students can use virtualization technology to perform some sort of very simple experiment in cybersecurity courses. And finally, I will share with you my observations and some student feedback on how virtualization technology helps and improves their learning. Okay. I believe as lecturers and teachers of cybersecurity, we all have different way of teaching and how we engage our students. But I can argue that we all have a common understanding or a common goal, which is how we can enable our students beyond the classroom. So in cybersecurity, I mean, in the context of teaching in cybersecurity courses, I identify these 4 main questions or 4 areas, which I've included in the summary of the presentation. So one of which is how we can, or achieving accurate learning outcomes and assessment that reflects the practical element of the courses that we are teaching, student expectations, as well as the industry changes requirement. Because of the nature of cybersecurity courses, things are always coming, new things are coming, and then we have to reflect the industry's changes requirement as well. In terms of time and logistics, I believe this is also a very a challenge for us. Because of the nature of the course cybersecurity, you'll find out students are spending a lot of time, which is good to some extent. But at the same time, we also have to quantify how many hours do they spend and what is the output of the time that they spend, their learning. And the issue of safe environment for student work, I mean, I believe we can all agree that one of the difficulties of teaching, not necessarily cybersecurity, but most of computer science courses is the universities and institutions have these restrictions of what students can do and what they cannot do with the university network, with the university's computer. So in that way, we need to answer some questions around, can the infrastructures, the lab environment that we are giving to our students, can the student have access to their practical learning platform at their comfort and at any time? Or will they be able to practice their learning in a safe environment with all the computer and network access privileges? So these are some of the issues and challenges. And another one is the issue of scalability, which I believe is very important, because we need to give students sound knowledge so that they can be able to scale their work even after they leave the university. So like every teacher, I ask my student, for example, in my cybersecurity class, what sort of topics are they more interested in? So for example, one of the questions that I asked my student in this semester is, what topics would you like to focus on through the semester? is quite interesting. So for example, you can see digital forensic here, it goes about 86%, 73% here, network security. Web security is about 73.3%, penetration testing, 66.7%, and then you've got a couple of other topics. So some of the observation I made in this data, I can see that my students are looking for job-related topics, something that can perhaps help them to get a job, which is good. And another observation I make here is some topics are difficult to be taught theoretically. Because, for example, if you look at digital forensic, network security, and even penetration testing, this will be extremely difficult to be taught theoretically in a way that students come with this sort of expectation. And then, it's difficult to teach these courses theoretically. And most of the topics require students to build a network of computers. And this is, again, another challenge because if, for example, it requires students to build a network of 3 or 4 computers, do we really give those students access to those computers to build that network? So that is one challenge. Again, I asked my students to tell me about how they want the course to be taught. I've got this response, about 40% they want the course to be taught 70% practical, 30% theory. Very interesting. 20% said they want about 80% practical, 20% theory, and of course the remaining around 60% practical, 40% theory. So my observation is students are looking for hands-on experience and hands-on learning. So it will be it will put one in a very difficult position if students have or come to the university with this expectation and they didn't actually meet those expectations. So this, I believe, this is one of the few challenges that I identified. Again, I asked my students, why do you want to attend the course? These are different responses. Actually, these are few, but some of the key words that I can highlight here, students are mentioning about career, interest, work placement, experience, and of course to finish a degree, which is good. So yeah, as you can see, it's a sort of challenge because students are coming with this expectation with for career, looking for something related to career, interest, and work, and then that will really put you in a very difficult position as a lecturer or as a teacher if there is no enabling environment for you to engage your student to get what they're looking for. Another challenge that I identified in teaching cybersecurity is the issues around the constructive alignment between indicative learning outcomes, learning and teaching method, and our assessment. So basically, when we develop programs or courses, we always try to put it in a very standard way that it can pass through the quality process and assessment, etc., etc. And to some extent, we play with these key verbs and words. For example, putting some expectation to the student that students are to create, develop, evaluate, and all these keyword that we are using while we are trying to reflect the standard that we are giving the student. At the same time, we also have to take into consideration the nature of how we deliver the courses and the assessment. So in summary, if you look at it, we are all trying to reflect on what is in the intended learning outcomes, which means our assessment method will have to reflect on this, and the learning and teaching method will all have to reflect on the intended learning outcomes. So suppose as a university lecturer, I was given the intended learning outcomes that require students to develop, or create a network, or or evaluate. And if there is no enabling environment to demonstrate this, it will really put you and the student in a very difficult position. So this is one of the reasons why I think there are a lot of challenges around teaching and learning cybersecurity courses, because you've got all this requirement and expectation from the indicated learning outcome, expectation from the student, because students are coming with all different ideas and interests, and at the same time, the expectation or the industry is changing requirement. So these are some of the few ways that I think we teach cybersecurity. For example, we use theory lectures to explain, describe ideas and the meaning of terms. We use case studies to discuss, to evaluate sometimes. For example, the strengths and weaknesses of security systems. Sometimes we use simulators, emulators, model checkers, for example, to some sort of evaluate or verify the accuracy of a security protocol. So we can only use this for illustration or to illustrate events, for instance, with limitation of approximations. And sometimes we use mathematics as a tool to demonstrate ideas, for example, in cryptography or in applied cryptography. So looking at all this, you can see each and every one, strategy or method of teaching has its own limitation. For example, with mathematics, we can only demonstrate ideas with approximation, but we cannot practice the actual event. But I think in summary, I can argue or I can say that with virtualization technology, we can be able to achieve, to practice. So not only that we can be able to, demonstrate to students, but we can be able to practice it more in a in a real, in a real environment. So what is a virtualization technology? Virtualization simply means the creation of a virtual version of computer. So the computers that we have today are very much hardware computers. But virtualization is more around how we can create a software version of computer. And the software version of computer that we create, we normally call it a virtual machine or a VM, which is a software implementation of computer that executes programs just like hardware computer. But before then, we also think about some of the infrastructures and the requirement for virtualization, which is the VMM or the hypervisors, which we need to install before we can sort of create the virtualization. So these are the three key things related to virtualization: the virtual machines itself, the hypervisor, and what we call the guest operating systems. So for example, you can look at virtualization concept in two different types. One is type 1. So in type 1, in this case, you've got a hardware computer that is a computer that you used, and then you install the hypervisor in the computer. You install the hypervisor, and then you install the guest operating system. So if you look at this type of virtualization, is you have hardware, you have a hypervisor, which is something that you can install. For example, you can use VMware, vSphere, Microsoft Hyper-V, or Citrix. And then you can now install different computers. For example, here you can have Linux. Sorry, Linux. You can have Windows here. Sorry with my handwriting. You can have Mac OS. So in summary, this is what it means by virtualization with hardware, the hypervisor, and the guest operating system. The other type of virtualization, which is type 2, and this is the most common one that we use in our classes, and I believe many institutions around the world, is for students to have the sort of the hardware component of the machine, and then they install their operating system. For example, if you're running Windows or Linux, you can install the operating system first, and then you install the hypervisor. And this hypervisor will now allow you to install different multiple guest operating systems. So for example, I want to create 3 machines. I can now create a Linux machine here. I can now create Windows. I can now create Mac. And the advantage of this is that students can use their computers not only for the virtualization, but for any other purposes, which means the virtualization in this case is just like a piece of software that they can install. And example of the hypervisors that we can use in this type 2, for example, is VMware Workstation, Oracle VirtualBox, and Parallel VMM if you're using Mac operating system. So these are two most commonly type of virtualizations that we can create, and there are different types of virtualizations which include application server virtualization, application virtualization, network virtualization, storage virtualization, desktop, and full virtualization. In this presentation, we'll be more focused on full virtualization, which actually gives us this power of creating the virtual environment. So these are some of the things around teaching with virtualization. One, as you can see, students can create more virtual hosts than the number of physical computers available in the laboratory. Students can create complex scenarios involving several hosts and servers, depending on the scenario. There is no restrictions of the number of network interfaces in each host that the student can create, because the virtual machine comes with multiple adapters, not like our hardware computers where we can only have one or two NICs. But in virtualization, you can have more than that. Students are also the administrators of their virtual host and servers, which means they can do so, they can do as they wish. They can install applications, they can delete it as they want. Students can create or can reproduce the experiment at home if they want. And this is another interesting feature of virtualization, which allows students to, for example, even have it in a piece of a memory with a USB or even hard disk. Okay. So virtualization allows you to do things that you can't do on a live network and frees you from restriction imposed by central IT support, who are very wary of allowing much of what is required for computer science teaching on general purpose networks. I mean, this is a comment by a friend of mine, or a colleague of mine, Dr. Mike. Let me share with you some example of this environment set of for using virtualization for networks, cybersecurity courses. So for example, this is an example of web security lab. So as you can see, in this case, we're trying to practice SQL injection attack and countermeasures, and we need at least, or a student need at least 2 computers. There's one computer here and the web server, sorry, and a server. So this is at least 2 computers. This is another example of a network security lab when students are trying to practice the use of reverse SSH tunneling to access an internal web server. To practice this, students need at least 4 computers. This is another example, DNS attacks and countermeasures. Students need at least 1, 2, 3 computers. So at least 3 computers. Another example, if for example, you want to teach your student how to build a virtual private network, students need at least 3 computers to be able to demonstrate this. This, for example, you've got 1 computer here, which is a remote access machine. You've got a connection between the remote access, the VPN server using internet. And here, as you can see, you've got another internal computer. And the target is for this remote access machine to be able to get access to this host machine or host B through the VPN server. So at least you need 3 machines in this case. There are some cases when students only need 1 machine. So for example, in digital forensics, most of the, or some of the, not all, of course, some of the exercise in digital forensic, student can use only 1 piece of computer. So what I'm trying to point out here, so suppose you have 30 students in a class, and 30 students, each one need at least 4 pieces of computers. And then how many computers do you need to provide to students? 4 times 30, 120. If you have 50 students, probably you need 200 computers or more, for example. And then if you said, okay, look, I'm going to divide these students so that they can use it in a different time, then the question will be around how many staff do you need to sort of, engage to support this student. So if you look at all this, is around logistics, the time that you need staff to support students, and the resources as well. One of the interesting issues related to virtualization or virtual machine is the network settings. So for example, as I mentioned earlier, if we are using a physical computer on our, in our classes, the maximum that we can have is maybe 1 network interface card for the computer. Perhaps we can have more than that, depending on the situation and the computer we are using. But with virtualization, you can have more than that. For example, these are different network adapters that students can set their machines. For example, if you look at NAT network, you can set it to allow your VM machines to have access to the internet alone. For NAT network, this one, you can allow the VM machines to connect to the internal virtual machine network, or you can, or at the same time, they can also send traffic to the internet. Host-only adapter, visible to selected virtual machines. So for example, host-only adapters, we can use these adapters for demonstrating or teaching digital forensic, or for example, malware analysis, because it actually didn't allow your sort of machines to connect to other machines or even to the internet, mainly because of the files that you are dealing with. Okay, and we've got a couple of different adapters, which it really make it exciting if you are using this sort of technology, in teaching some of the ideas. Building the lab environment, I believe this is one of the most tricky part of it. The question is, how can we build this sort of virtual lab environment? It is very simple to some extent, but as you can see, one is you need to create the hypervisor. So by creating hypervisor means you need to install the hypervisor. For example, if you're using Oracle Virtual Machine as hypervisor, then you need to install it on your hardware machine. The next thing, of course, is to create the VMs itself. So when you install the hypervisor, then you can create the virtual machine. You can create it where you can define the hard drive, the size, the hard drive sizes, the RAM sizes, and you can also specify other parameters. And the next step, of course, is to install the version of operating system that you want to use. For example, I can use Linux, Windows, Mac OS, Android, or any sort of operating system that you can use in your class. And the next thing, or the next step, is to configure the VM itself. So this is where you can configure the virtual machines, the general settings. Maybe if you can, or if you want to allow the sort of a bidirectional communication between your hardware machine with your virtual machines, or you can enable input-output APC. So this is where you can all set the configuration. Building a virtual network with VMs. So again, this is where you can set the network. For example, if you want the virtual machines to only communicate with the local networks, then you can set it to maybe host only machine or host only, or you can select the NAT network adapter depending on the nature of the lab you are you're doing. You can also set the virtual machine adapter to be in a promiscuous mode, which is a monitor mode that allows your virtual machine to not only snip the traffic within the virtual machine, but within the network where your host machine is connected. The next step is to build and configure other services. Sometimes we need to configure the server itself. So in that case, you can configure VPN server, DNS server. You can configure all sort of services that you want in your network. And the final, or the next step, obviously, is to install software packages. This actually depends on the topic of cybersecurity that you are teaching. For example, it can be web security, network security, digital forensics, etc. And then you can now use or install all the different applications and packages. I try to summarize some of the tools that we can use for this sort of installing packages. But I have to admit, this is not, the all list. There are many other tools that we can use. But the good thing about this list is most of the applications are free and open source applications, which means you can easily install them free of charge. So, for example, for wireless security, we can use different tools. For wireless security, for example, AirCrack is one of the most simplest one to use, and students enjoy it most often. Packet crafting, very much related to network security. For example, Skype, I found Skype as a very handy tool, but in terms of simplicity, network is a very much simple tool to use. Applied cryptography, of course, this one we use different programming languages. For example, C, Python, and Lua programming language. I mean, the reason why Lua, most of institution teach Lua programming language, because that is the language which the NMAF was actually developed, and students can write their own script, which makes it very handy. But in terms of other packages and libraries, nowadays Python is taking the ground, mainly because it has these very rich libraries and it's very simple as well. Vulnerability exploitation, there are different tools, but one of the most commonly used one is port scanning, NMAF, NetScan tools, SuperScan. All these are free and open source tools that you can also use. I would like to highlight here, which is cybersecurity project. There are different other cybersecurity projects that one can look at, but Kali is one of the tools that a lot of teachers, including myself and many, are using. Metasploit and SeedLab. So these are some of the cybersecurity labs or machines that one can use for digital forensics. These are some of the list. Again, as I said, this is not all list, but most of the applications in this list are free and open source. I mentioned about Kali Linux earlier. So Kali Linux is an advanced penetration testing tool that we can use very conveniently in our classes. It's a Linux distribution aimed at advanced penetration testing and security auditing. Hundreds of penetration testing tools are already installed on Kali Linux. It's an open source. There is a zero penetration test Kali Linux version available, which means students can easily use it from the cloud. You can also build a customized Kali ISO image. It's also very easy, fun, and rewarding. This is one of the comments from students. And you can also run a Kali on a live. You can run Kali live from a USB drive on standard Windows and Apple PC. So which means you can you can use it from your sort of USB, and which is very comfortable and very convenient to use. SeedLab, I found this very sort of rewarding for students, which is a hands-on laboratory exercise. It's called SeedLab for Computer and Information Security Education. There are different labs, for example, related to software security, network security, web security, system security, cryptography, and mobile security. It's a very interesting lab, and I do encourage lecturers or teachers of cybersecurity to look at this lab. There is a cloud ready or cloud version for SeedLab, which you can now create a Seed VM on the cloud. And one of the interesting about SeedLab is the project is now available, which means you can download some of the code, you can modify them, you can use it in your classes, which is again very convenient. There are other virtual lab environments for teaching cybersecurity. Digital Lab is also one of the very interesting one, which was actually developed by Terry from University of Southern California. Again, this is also a cybersecurity lab. TELLab is a web-based training system, which means students don't have to install it on their own machine, which they can log into the system and use it for different purposes. And of course, it's mainly used for offensive security training. So which means, for example, if students want to try some ideas related to attacks and countermeasures, that is a very good tool to use. Okay. And so these virtual labs can facilitate cybersecurity experiments whereby students can configure a number of network virtual machines and embark on security offensive and defensive exercise. In terms of virtualization technology assessment, there are different ways that we can assess student work. One of the example here that I'm given is the use of screenshot. For example, this is an example of a question. Students are asked to find a vulnerability in a given web server, and the question goes like this. Cross-site scripting vulnerabilities allow attackers to spoof content, steal users' cookies, and even execute malicious code on the user's browser. Many web penetration testers use the Nmap scripting engine to discover these vulnerabilities in web servers. Students, your task is to use either Nmap script or any method of your choice to scan a web server looking for file vulnerabilities to XSS. You are required to use only given the. So this is a question. And in a simple way to answer this question, a student can write a one-line command of script and they can all get what they want. And because this is what I'm looking for. So for example, student can include this screenshot with, of course, an explanation of what the observation is. But obviously, if you can see here, it tells you that this script was run and it couldn't find any CSRIF vulnerabilities. That is all I'm looking for. I'm also looking for this. That is all I'm looking for. I'm also looking for this. And I can see the number of ports that this particular student tested using this script. So actually, this is the name of the script, vulnerability script. And so with all this information, students can easily and conveniently demonstrate their learning and demonstrate their achievement. Another example of using virtualization technology for assessment is using, sorry, just. It's using assessment with screen captured video. So for example, student can use a virtualization. There is a features of built-in virtualization or in a virtual machine that can allow students to record the video screen of the virtual machine, which is quite very handy and to some extent very easy to use. So student can record the activities and they can also include it as a link, or they can even embed it in the in the document they are including as part of their assessment submission. Another example is student can also submit the actual hard disk file, because the whole virtualization is a piece of software, which means they can submit the virtualization or the virtual machine itself as evidence for assessment, but they can also submit the hard disk file of the virtual machine. Okay. In terms of assessment, we always talk about the anonymous marking. Sometimes, especially when students are using computers, they can easily sort of forget to include their names. And if your institution have a policy of anonymous marking, it really put one in a very difficult position. And this is by default. Sometimes if students create a virtual machine, then it comes with their name. So for example, as you can see, my name is here because I created this virtual machine with my name. But again, student can change this or can easily change it. For example, they can edit this bash file, or they can just write this command on their on their terminal, and this will automatically change the names of the student to student ID. And this is what we normally encourage students to include their ID, not necessarily include their names. So for example, as you can see the student ID, so in this case, you can only see the student ID without seeing the student name. So that is for the assessment. Building learning portfolio with virtualization technology. It is very much convenient and easy for students to build a complete learning portfolio using the virtualization or the virtual machine features, which is called snapshot. So snapshot is just like a backup, a backup or recovery sort of or point of restoration, which means students can keep different versions of their virtual machines, which they can easily sort of build a learning portfolio. Sometimes, even because of the nature of these virtual machines, it's a piece of software that requires a constant and frequent update. It's always good for students to keep this record, because sometimes virtual machine is easy to crash. So in that case, if students have this sort of backup, it really helps to sort of build their portfolio. Okay, I've got a sample of practical experiments to demonstrate, if you wouldn't mind. The first one is how we can use this sort of virtual machines to sort of, you've got a machine here, which is a server, you've got an attacker machine, and you've got a client machine. So in this case, we're going to see how we can use this sort of simple lab to inject data onto the TCP or UDP connection. This is one experiment that you're going to see in the next few minutes. Another example is how students can use two machines. One is an attacker machine and another one is a server, to try this SYN flooding attack, which is very common and very simple sort of attack. Okay, so let me again. Can I confirm if you can see this sort of my screen, Oracle VMs?
Yep.
Oh, brilliant. Thank you. So this is an example of how it looks like. I mean, if you're seeing it for the first time. So for example, this is my hypervisor, which is a virtual machine. As you can see, I'm using Oracle VM VirtualBox Manager. And I've got all these set of computers. So each and every one here is a computer itself, or is a machine itself. Of course, I can create more lists of computers. This is an example of different screenshot, which is a backup of machines that have been taken. So normally, for example, I can take a backup machine after every month, or depending on. Okay. So in this case, I'm going to start one machine. I'm going to start another machine. So I'm going to use these two different machines. Sometimes it takes. Sometimes it takes a few minutes to load, but yeah. Okay. So again, talking about the features of this sort of virtual machine. So if, for example, I want to sort of create the network of these machines, all I can do is to some sort of select the machine, check the network settings, and then I can now, I think, yeah.
It always takes sometimes, not sometimes, always takes sometimes. Yeah. But I found it very beneficial, the part that you said about the screenshot, because I use virtual machines, but I didn't know that. I always teach students how to take screenshot for assessment, but I didn't know that it's built in, actually, that they can do it, which was very beneficial, really.
Oh, thank you. Yeah. Sometimes it's it takes time, but yeah, I don't know why. This one is. Let me try. Okay. I think let's continue with the presentation. Possibly by the time when it finishes, you can be able to see this. So yeah, one of the, if we can continue with the presentation, one of the interesting thing about the use of virtualization is the new technologies that are constantly emerging and coming up. So for example, yesterday we were talking about virtual machines, but today we are talking about containers, or containers. So a container is sort of a light version of virtual machines that allow you to some sort of exclude or create processes rather than the virtual machines. So this is a sort of advancement of the use of virtual machines. So for example, if you look at this is the architecture of virtual machine, you've got the infrastructure of your computer, you install the hypervisor, and then you install the guest operating system. Container is different from this architecture. And as you can see in container, what you do is you have the infrastructure, the operating system, and then you've got a container engine. And in this container engine, instead of you having multiple guest operating system, you're now having the instances of processes rather than the virtual machines. So this really makes life easy in a way that the space that you need to create this virtual machine network, you're now replacing it with possibly with one guest operating system with different instances of the of your programs. So one of the differences between container and the virtual machine is that using container, you are not dealing with the virtual machine itself, but rather you are dealing with the processes. So this makes it a kind of a light version of the operating system, of the virtual machine, and it's easy to start, only a few seconds, and less operating system maintenance, because with virtual machine, you have to maintain each and every sort of operating system. For example, as you can see, I'm trying to start one operating system is running, but the other one couldn't actually let it run. In terms of challenges, these are some of the challenges that I think or that I found using virtualization technology. One is issues of backward compatibility. So for example, if you have a machine that is not good enough, or that is for, like, for example, 15 or 20 years back, it will be difficult to run virtual machines. You need to have a sort of a good and decent pieces. And there is an option, of course, of using cloud service, but again, this is also another issue. So some students, of course, are finding it difficult to have sort of good, PC to host those machines. Another issue is the issues of backup. Sometimes, because of the nature of virtual machine, we need to frequently, save the state of our machines. So this is also very challenging. Sometimes students may forget to save the state of their machines, and then they lost everything. It happens. So yeah, but I believe the solution is for students to take snapshots. That will possibly help. There is the issue of security, because the virtual machine itself is a piece of software. So, which means handling it should be with care. So for example, unlike some technologies, solutions, virtual machine is not really a set it and forget it. It's something that you have to constantly update and upgrade. So that is an issue. Another challenge that I found is the issue of learning curve. So generally, there is a misconception that virtual machine or virtualization is difficult to learn. I disagree with this, but yes, I can admit that it is challenging to some extent, but I believe with training and practices, students and teachers can easily use it. And these are some of my observations with the using virtualization technology in my classes. Virtualization technology solve the logistic problem associated with hands-on activities. So far in this lab or in my lab, I don't need sort of student to be using all the resources but we can be able to demonstrate some ideas using virtualization technology. It also helped to improve interaction with students and enable more content coverage during my classes. More hands-on project assessment are more aligned with ILOs and comprehensive. In terms of coverage of material, I found this is really, the coverage of material really increased, because you can easily achieve many things with VMs or with VT. And I found it interesting to some extent when students are always coming with different problems, different issues. That really create this environment of constant engagement between myself and my students. So these are some of my observation with virtualization technology. Yesterday, I asked my students to, mainly for the sake of this presentation, I asked them to give me some feedback on how they use virtualization. For example, I asked them a question: given your experience using virtualization technology, do you think it helps students learn and improve student skills with the course? About 75% students says they strongly agree, and 25% says agree, which is good. I also asked them a question: do you think using the virtualization technology, or do you think the VT gives you access to your practical learning platforms at your comfort and at any time? About 65%, 62.5% says strongly agree, 37.5% agree. I equally asked them, do you think using the virtualization technology increase your engagement, number of hours spent with your learning? About 50% says agree, strongly agree. Agree to 12.5%. Neither agree, no disagree, about 37.5%. On the question, do you think using virtualization technology enable you to scale your work and demonstrate your learning from anywhere? 25% strongly agree, 62.5% agree, 12.5% neither agree, no disagree. Given the time you spent getting your head around the virtualization technology, do you think it is worth doing it? About 50% agree, 37.5%, sorry, about 50% strongly agree, 37.5% agree, neither agree, no, disagree 12.5%. I also asked my student to comment on the use of VT. Please provide any comment on your overall experience with the use of VT. This student says that the networking in the in the VMs is fiddly. I agree. This one says, initially getting my head around of the VT was difficult. However, it will slowly become more clear. I believe some of the courses will be useful in the industry. However, for me personally, I will prefer to pursue a career in web development, which is great. Another student says it is great. And this student says use it before, so it wasn't a new concept to me. However, I had never created my own little network and play around with packet capture and hacking concept in a realistic manner before. So I have really enjoyed the use of VT. And the last question that I asked them was, what advice will you give to another student taking the module regarding the use of VT? And this one says it is tricky, but so was doing. Mess around with the settings in your own time to understand how it all works. And this one says, make sure your environment is set up early to avoid further complication in future weeks. Okay. So yeah, thank you. If you don't mind, if I can check this. I don't think this one is. Okay. Unfortunately, I don't think this will allow us to some sort of demonstrate this. But yeah, if you have any question, I'll be happy to answer any question, please. Any question?
I guess we have questions in the chat.
Okay, the chat, sorry. I'm using multiple screen. So I think if I'm to start with a question from Alison, have to leave for the excellent presentation, extremely informative. Thank you. Thank you, Alison. And this one is asking a question. Excited from student, what topics, okay, eliciting from student, what topics they like and how they want to be taught is truly student-centric. Really well done. I mean, illustration for how you are managing practical aspects is very useful. Thank you for taking time to share your teaching extra highly educational. Thank you very much. Yep. Leave. So yeah. I suppose there is no specific question. The one that I can see are very much comments. Again, yeah. So if you have any question, you can either.
Yeah. There was one question from Richard. I guess he's asking, what sort of activities do you get your second-year students to use it? Richard asked a question about
what sort of activities. Yeah, I'm just trying to get it. Sorry, I'm not sure if. Yeah, Rasha, can you help? Can you repeat the question, please?
Oh, yeah, sure. Richard from your college is asking, what sort of activities do you get your second-year students to do with the virtual machine lab?
Okay, that is a very good question, to be honest. I think I can start with the first year before second year. So for example, in the first year, in one of our modules, technology in context, we normally introduce students to some sort of, to play around with the virtualization technology. Because to be honest, sometimes it takes time before students get used to it. So that is for technology in context. In our second year module, there is a networking course. It happens, I'm the one that I've been teaching it. And we use virtualization technology for the whole sort of experiment that is in the second year. And so the third year, of course, we use it for cybersecurity and related courses. So yeah, to answer that question, in our networking class, in the second year, we use it. And if I can also recommend to lecturers who actually want to adopt it, I believe the best way to go about it is to give students sort of experience to play around, is to play with it even before the time when they need to actually use it. And I also encourage lecturers to consider teaching students Linux programming or Linux administration, because most of the activities that we do in cybersecurity classes are very much require the knowledge and the background of Linux administration. So if, for example, you consider teaching Linux administration in your class before cybersecurity classes, it really helps. Thank you. I hope that answered your question. Not sure if there is any. Okay. Thank you, Richard. Okay.
Can I just thank Aminu for a fantastic presentation and thank everybody for attending.
Yeah.
If you have any more questions, you can email us at yhiotadmin@yorkcollege.ac.uk and we can pass them on to Aminu on your behalf.
Thank you very much, Sally, and thanks everyone. And again, yeah, I'm happy to respond to any question if there is one. And thank you very much all.
Thank you.
Thank you.